All right, example 2, reminder, we still round to the nearest minute. And we are given cosine of theta is equal to 0.788. And let's be in quadrant 1. And before I get any further, because it's going to slip my mind, you all reset your calculators earlier for the quiz if you had it out. So your calculator is more than likely in radians mode as the default. So check your calculator, make sure you are in degrees. Go ahead and make that change now. If you're in radians, you will not get any of the values I'm about to get. Once again, that's done under mode. Mode is all of your calculator settings. For me, it's the 4th option down. Make sure degree is highlighted. On this calculator, it says it at the top, so you'll know if it's in the right mode or not. First things first, let's just start with an image to work with. Again, this is a very rough graph because we don't have a lot of information, so it's more of just a visual tool at this point. We're in quadrant 1. There's our angle of rotation, which is theta. Alpha, x-axis up to the angle that we drew. And then it's helpful to recognize that the right side of that x-axis is 0 degrees, just for reference. So just like I said the first time, the first thing you need to do is find alpha using the inverse. And in this case, it's going to be of cosine. Alpha is inverse cosine. And then it's of whatever value they give us in the original problem. And if I haven't said it before, on these problems, I am leaving out quite a bit of context because the deeper I go into explanations, the more confusing it gets. So I'm intentionally leaving out some things. If there's something you're very curious about, we can talk about that one-on-one. Otherwise, just know, take the inverse. And then we're going to use our calculator to get that number in degrees, minutes, seconds, rounded to the nearest minute. So if you just have a decimal, you haven't done enough. So we need to do inverse cosine, 0.788. There's that decimal. Don't round that. We're not done yet. Now we're going to convert to DMS, so second, and then the apps button to get into that angle menu. And we go down to the 4th option to convert. And there we have it. And this one's actually going to be nice. We have 38 degrees, 0 minutes, and then is it going to be 0 minutes or 1 minute? 0 minutes. We only have 3 seconds. We're not bumping that up. So 38 degrees, 0 minutes. And we do want degrees, minutes, seconds format, so it feels a little ridiculous to put the 0 minutes, but that is making sure you're writing it in the correct units, so keep it like that. There's our alpha. Next we find theta. And these are those same old quadrant rules that we used on that whole last test. We're in quadrant 1. Alpha and theta are clearly representing the same angle. So this time theta is actually just equal to alpha. So no extra math here. Theta is 38 degrees, 0 minutes. This process becomes very automatic after a while. You just have to know the steps. Questions on example 2? There are a couple more things I have to show you. Example 3. I'm not going to write it, but again, round to the nearest minute. We're going to do that every single time. We are given tangent of theta is equal to negative 1.257. And let's be in quadrant 4. First, start with an image, mini graph. We're in quadrant 4, so we're going to draw in our angle. Angle of rotation, labeled with theta. Alpha goes from x-axis to the angle drawn. And for this problem, it's helpful to recognize that the right side of the x-axis will represent a whole 360 degrees. So again, first step is to find alpha. There's a rule I need to remind you of. Alpha is always what? Positive. Can't emphasize that enough. So that's a sneaky little rule you're going to have to remember when you do these problems. So when I go to take the inverse here, notice that's a negative number. So take off the negative. It's as simple as that. So we're going to use inverse tangent. This time of positive 1.257. That's why the sign disappeared. That was not a mistake. And then we'll use the calculator to get that number. And I'm going to show you, it's not a major shortcut, but it'll help. Anything that helps. 1.257. Before I hit enter, type in your calculation and then go ahead and attach the conversion after it. That way it does it automatically. So I'm going to go ahead and put that DMS afterward. So second apps, fourth option, and then it'll spit out my answer and the correct unit. Saves you just a little bit of time. 51 degrees, 20 or 30 minutes? 30. 46 seconds, we definitely have enough to bump this up to 30 minutes. 51 degrees, 30 minutes. We never write seconds. And theta. Again, that's just the rule of whatever quadrant you're in. We're in quadrant 4. Theta is the full circle minus alpha. 360 minus alpha. Now I'm just going to do that in my calculator. Reminder, once you have that number with all the symbols, just bring it down to the next line and take out what you don't need. And now I don't have to type all those symbols by hand. And I forgot, this is the decimal, so now I got to flip it back to degrees, minutes, seconds. So second apps, convert. That's better. 308 degrees, 30 minutes. And be careful here, the minutes aren't always preserved when you do the theta calculation. That happened because we were exactly at half a minute. If this weren't 30 minutes, then it wouldn't have been preserved. So always use your calculator to do that. I've got one more of those. Again, it's a slightly different type of problem. Example 4. Given cosecant theta is negative 2.749, and we are in quadrant 3. Again, let's just start with a visual. Draw our angle in quadrant 3. Angle of rotation labeled with a theta. Alpha goes from the x-axis to the angle. And this time, let's recognize that the left side of the x-axis is 180 degrees. Now, I'm not going to write it out, but I want you to visualize when we did those graph problems that had the 6 trig functions you had to fill in. We're going to come back to that in just a moment, actually. Cosecant is one of the reciprocals. So we have cosecant here. Cosecant is negative 2.749. What's the reciprocal of cosecant? Sine. Now, if you know that this is the value of cosecant, how do we get to the value of sine? Exactly. I was about to put that over 1 as your hint. Just flip it. That's how you did it on the test. Same thing here. Just flip it over itself. Now you have what you need. Now we can continue and use the calculator to get everything else. Alpha, we take the inverse. So inverse sine. And then we're dropping that negative because negatives are not allowed for alpha. 1 over 2.749. Calculator to get that answer. Inverse sine, 1 over 2.749. And then if you remember, go ahead and put that conversion at the end of that. (21 degrees, 19 minutes, 54 seconds. So 21 degrees, 20 minutes. And again, theta, we just need to use our quadrant rule. We are in the third quadrant, which if we take the full theta and take out the 180, or sorry, take out the alpha, we're going to get what's left. Sorry, I said that completely backwards. Theta minus, God, why am I overthinking this? 180 plus alpha. There we go. 180 plus the alpha. And again, I'll just do that in my calculator. And then convert. 201 degrees, 20 minutes. As far as that goes, that's as tricky as it's going to get. Any questions on these types of graphing problems? Okay. I've got another type to show you. Graphing alpha and theta given a point. This one is going to be very easy to overcomplicate. When you see this on a test or a quiz, we like to give the point a name, and we always use the letter P. So just know that that is just the label of the point. It is not some bigger symbol or representation of anything grander than that. I'll have to make a note about that if you want to write it down. All right, first off, let's graph. Now we have an actual point, -2, 3. So from pre-algebra, we are literally going to graph that point. Now we're still going to construct this in the usual way. So we're going to draw our angle of rotation with the theta. Alpha goes from x-axis up to the angle we drew. This time, we don't have a trig function that we're given, so we can't just solve, get our theta and alpha, and go on our merry way. So this is where we're returning back to the triangles. So I'm going to make a note about that if you want to write any of that down. No trig function given. Need to make a triangle. So we're going to go from the point to the x-axis, create that right angle. And just so you know where we're going with this, the full goal of this problem is to get all the trig functions plus theta and alpha. So knowing that, that's going to kind of alter our direction here. I'm going to go ahead and fill in those blanks now just so they're down there. We have sine of theta, cosine of theta, tangent of theta, the reciprocals, cosecant theta, secant theta, and cotangent theta. And at the very end, we will figure out theta and alpha. That'll be the last thing we do. Let's get back to the triangle. We already know two of the side lengths, and they come directly from our x and y. The bottom, the horizontal, has a length of -2, and the vertical has a length of 3. How do we find the third side?
B squared, C squared.
Exactly. It's a right triangle. We use Pythagorean theorem. H, the hypotenuse, our missing side here. So what am I solving for, A, B, or C?
C.
Yep. C is always hypotenuse. So we have 3 squared plus -2 squared and H squared for the C squared. 3 squared is 9. Now I'm only asking because I will see it happen in this class. What's -2 squared?
4.
Thank you. +4. I will have someone put a -4. Someone will do it. Don't let it be you. H squared. 9 plus 4 is 13. And then we need to get H by itself. I intentionally left off the plus or minus. Why did I do that this time? Exactly. So there's no need for the plus or minus here. It has to be a positive. H is always positive. So no question, it's just the square root of 13. So now we know the H, square root of 13. We can fill in all 6 trig functions. Let's start with sine O over H, and let me label real quick. O is the vertical and A is the horizontal. O over H, that's 3 over square root 13. Can't have a radical on the bottom, so let's get rid of it. Times square root 13 over itself. 3 square root 13 over just 13. Cosine A over H, that's -2 over square root 13. The work for that is very similar to sine, so I'm just going to jump to the answer if that's okay. -2 square root 13 over 13. Tangent O over A, that's just 3 over -2. And then all the reciprocals. With sine and cosine, I'm going to flip the original and not the new to avoid extra work. So cosecant is square root 13 over 3. Cosine is secant is square root 13 over -2. Tangent is just -2/3. Finally, we find theta and alpha. Just like the previous problems, we just need a trig function, and we take the inverse to find alpha, use alpha to find theta. This time we have all 6 trig functions. Of course, we can only use sine, cosine, or tangent. And reminder, alpha is always positive. So to make this a tad easier on yourself, choose the positive trig function to go with, just so you don't have to remember to take off the negative. So I'm going to write that down here into the alpha. Choose the positive trig function to find alpha. Just make it easier on all of us. In that case, that is going to be sine. Sine is the only positive trig function. So we're taking the inverse sine. Now listen up carefully because this caused some confusion yesterday. You can take the inverse of the original or the final answer. They are the same thing. I hope you understand that these are the same value. It's just which one's the proper way and which one's not. So for typing into the calculator, I'm going to use the improper version. It's just a little faster to type in for me. But you can do it of either one. You'll get the right answer. Just want to put that disclaimer out there. I'll use the calculator to get that number. Inverse sine of 3 over the square root of 13. And then, since I'm remembering, I'm going to go ahead and do the conversion as well. 56 degrees, 18 minutes, 35 seconds. So this is going to be 19 minutes. 56 degrees, 19 minutes. And lastly, we can find theta. We are in quadrant 2. Helps to recognize that the left side is 180. So 180 minus the alpha will get us theta. (180 minus), and if I haven't been clear before on the copy paste, I just arrow up, highlight that, enter on it, and it'll paste it on the next row. I use that all the time. I'm going to change that to 19 minutes and then convert to DMS. 123 degrees, 41 minutes. And there you have it. There's one more type we're going to explore. It's not new. It's just taking something we've done last unit and doing it in this unit. So it's not going to feel super new when you see that on Monday. But we're going to stop here for notes today.